We are live here, so please tell me once that my voice is clear to everyone so that we can start with the class. Yeah, voice is completely clear. Hello बच्चों, नमस्कार, आदाब, सत श्री अकाल. How are you all? I hope that all of you are doing very good. I think so very soon your 12th board physics exam is also going. Okay. So I hope that you are prepared very well. If you need any extra assistance regarding that, please contact to our team. We are there to help you in every single possible way, individually, as a mentor or as a guide for future, for how to tackle all those things, because you have JEE, NEET, respective exams you would be having. So all these things. And for the moment, we are here on going 11th marathon revision session. Yesterday we have covered units and dimensions. We have seen every single aspect, nearly how to tackle the questions. Obviously we are in marathon series, so we are not going into the depth of the questions, but we are handling that what are the basic concepts, so that we can able to solve a lot of questions. On the basis what we are revising this, you also have to work a lot harder from your side to get the complete output, because it's, you know that physics is all about practice. If it would be so easy that you are watching a 1 hour lecture and you will be understanding the complete chapter, it's not the case. Once you watch this lecture, you know the basics. I am going to again brush up all those basics, how to write the formulas, how to apply those formulas in the, what are the critical points that you keep remember, where you can make the mistakes, all these things we can brush up. But the practice will only can make you perfect. Okay, so at the back end you have to put in a lot of questions. Let's suppose what is will be the today's topic. I will give you the overview. Firstly, we are going to start from laws of motion completely. Laws of motion will be understanding how to write the equations, how to draw the FBD, what is pseudo force. Then we'll be moving to work power energy. Work power energy will understand about the work energy theorem, that is the most important thing, energy conservations. All these things we will be understanding, and then we'll be applying that in vertical circular motion. You know that vertical circular motion, that is the application of both Newton's law and work energy theorem. So in complete depth, you know that their conditions come. So what is the minimum velocity, sir? Along with this, friction will also be there. I will tell you about the friction. A lot of people get confused that what is limiting friction, what is static friction, what is kinetic friction. So these things will getting brushed up, but when you will get to master it, when you are putting a lot of hard work back into it, you are solving 50 questions, 100 questions, 200 questions by your side. Okay, so it is a combined effort. Okay, so it's I will never say that 1 hour of lecture will make you the master of the subject. It's never the case. If it would be so easy, then every single one of India will be IITian and okay, so that is the fact that I will tell you. Fine, so without wasting any further time, let's begin to our session. Okay, interesting session starting from laws of motion. From the basics, we have already seen the motion. Now we will see the cause of motion, that of why that motion is coming, how that motion is coming, when if any body is having a velocity v, how that getting the velocity v. Okay, who is giving this velocity v? So when you apply some force, then it is what the you will be getting your velocity v. Okay, I guess that before starting, you know about the basics of force, tension force, normal force, laws of motion. What are the Newton's three laws? What are the Newton's three also? Tell me. First law, we'll talk about laws of inertia. Second law, rate about force is also rate of change of momentum. Rate of change of momentum. This is very important. Actually, a lot of questions comes from here because it is give you the qualitative analysis also, and as well as quantitative analysis, because problem solvings will be coming. Third one, every action has the action and reaction pair concept of forces. That is the Newton's third law. So these basics, I will be hoping that it will be clear, and we will be building the revision on above that. Okay, so let's start the chapter. Fine. तो शुरू करते हैं बिना किसी देरी के. See, first one is normal reaction. What is normal reaction and friction? See, normal reaction is a kind of force that always applied to the perpendicular to the surface. Let's suppose this is the surface and there is a block that is moving on this surface. Let's suppose my hand is the surface. So normal reaction will always be perpendicular to the surface. perpendicular to the surface, not perpendicular to the horizontal. What will happen if I will give an angle to my hand? That means normal reaction will again become perpendicular to the surface. That means now a normal reaction will be looking somewhat like this. Friction is always towards the surface. It is always act along the surface. Friction always acts along the surface. And what is the tendency of friction? Tendency of friction is to oppose the motion. Even if you're in your mind you are thinking, so I am trying to move, even in your mind also you have thought na, that I am trying to move downwards, it will automatically apply upwards. Always oppose the tendency of the motion. And the combination, the resultant that you will get is called as contact force. The resultant of this normal and friction, this is called as contact force, and this angle is also a angle of contact that we'll understand in majorly in friction topic. Okay. Here is the question: draw the normal reaction for the following cases. Tell me what will be the normal reaction for all these three cases. How you'll be drawing the normal reaction? What I've told you, to the common surface, apply normal reaction always perpendicular to the common surface. Okay, to the common surface. See, here is a body. What will be the tendency of this body? This angle is at theta. क्या हुआ? Who has opened the byte mode? Wait a minute. No whiteboard is opened here. Oh, भाई साहब. No, it is okay. Fine. Fine. Let's begin. So if we have to draw the normal reaction, how will be drawing the normal reaction? This is the common surface, I will say. This is the common surface, and normal reaction will be acting perpendicular to it. That means it will be 90 degree to the surface. Simple logic of normal reaction. It always acts perpendicular to the surface. That's it. Let's suppose here you want to draw this. This is the, can I say these two are the common surfaces that you will be having? Yes or no? तो बताओ कैसे बनाओगे normal reaction? Normal reaction, just draw it perpendicular to the surface. Just draw it perpendicular to the surface. Correct? This will be what? Your normal reaction. See here, these are the two balls. How will be drawing? Can I say this is the common surface that you will be having? That means I can say this ball will be applying normal reaction on this side. This will be the normal reaction on this side. As of now, I'm not naming any force. I am just drawing the FBD. I am just drawing what the FBD. I hope that all of you know what is FBD. FBD is what? Free body diagram. You know that laws of motion. If you are able to draw the FBD properly, you are confident in drawing FBD. That means done. Laws of motion is done. Yeah. After that, writing equations is not the typical part. Drawing FBD, I always say in physics, if you are mastered in diagrams, if you are mastered in drawing, then physics is nothing. Okay. Master the diagram, master the physics. Simple logic. There is nothing complication. Master the diagram, master physics. Simple as that. But you people think that why to waste time making diagram, and you people think most of students I have seen they hesitate to draw the diagram. I don't know why. Or even if they will draw in the somewhere corner upside just to show off. Why? In diagram itself, a lot of questions get solved. Or actually it will give you the lot of good concepts. So always don't get afraid for drawing the diagram. Diagram is the most important thing, I will say. More than important than writing equations is the diagram. That is what I think. Okay. See. So now let's move to the next one. About tension. How tension force act? Tension force always act. Let's suppose it is very obvious thing. Let's suppose you are pushing some string or a rope or anything. So what will be happening in that wire? A strain will be generated. So I can say that force or that pressure that is getting generated, that force in the rope is called as tension force. That force is tension force. How to represent tension force? Tension force always act away from the body, along the rope, along the string. Mostly in this chapter we are going to use string, so that's why I'm using the word string. Always it is going to act away from the in away direction. Let's suppose here you are applying force, tension will be applied away direction. Here will be same force, action reaction pair will be acting. So here also you can see that it is away from this hinge point. Okay, so from the point of from where you have to draw the diagram, it will always be acting in the away direction. Correct? See, there is a question. Let's try to tackle the question. What the question is saying. Read the question. what the question is saying, a block of mass 2 kg on a frictionless plane inclined at 60 degree. Frictionless plane is there and a block is there of mass 2 kg, that is also mentioned, and the angle that at which it is inclined is 60 degree. Okay, with the horizontal is supported using a string attached to the body and held at an angle of 60 degree to the plane. Here it is a string that is attached to the body and it is at 60 degree to the plane. Compute the tension in the string if the block is stationary. You have to calculate what will be the tension if the block is stationary. If the block is stationary, that means can I say that nothing is in movement? Nothing is in movement. So now draw the FBD. I'll be drawing the that FBD. Tell me what will be this force? What will be this angle? So that you can calculate the complete angle also. This will be what? 60 degree. If this is 60, this will also be 60 degree. So can I say from the horizontal, this actually the diagram is not drawn properly. So the complete angle will be nearly 120 degree. So now draw the FBD anyways. This will be what? mg. That means 2g. This will be what? 2g sine 30. This will be what? 2g cos 30. Now I hope that this is clear to you. Is this clear to you? How I have drawn the FBDs? See, this was mg. You know now how to take components. Component in aata, along the angle it is always cos component and away from the angle it is always sine component. That means what I can say, if this is my mg force, if this is my mg force, this will be what? This will be angle 30. This will be what? Angle 60. That means this will be mg, this will be theta. I can say this along theta, it is which component? Cos component. That means 2g cos 60, and here it will be 2g sin 60. It is 2g sin 60. Sin 60. Yeah. Correct. Now what about normal? I can say normal will be acting perpendicular. Normal will be acting exactly perpendicular. How you can make? Now just make the component of t in both the directions. Along one is along the perpendicular direction, so that it can equate directly mg, and obviously normal is equals to 2g cos of 60 degree, because nothing is in movement. So just equate. This is the condition for equilibrium. Just solve in the diagram itself. It is solved. Is it clear? So make the diagrams, make the angles properly, and just equate it in all the equal opposite directions. Correct? Very good. Here for you the complete next one. Momentum. Now what is momentum? Momentum also comes with force. Momentum is equals to mass into velocity. Let's suppose you have applied some force. You have applied some force on a body and you have lived. So now the body will start moving, correct? The motion that you will be having, that it will, why it is going on, due to, we call it as momentum. When you give any impulse, actually we call it as impulse. Let's suppose you have given some impulse on the body and now it starts moving. So what I can say, that body is having some momentum. What is that momentum? Momentum is mass into velocity. See, momentum is a quantity object possessed by an object by virtue of its mass and motion. It is also known as quantity of motion. How much motion is there, that is defined for momentum. So momentum is also what I have told you about the formula, mass into velocity. Second important thing, that it is a vector quantity. Whenever you represent momentum, you will be representing it in vector form. Correct? For example, let's suppose for this body, if you want to write momentum, mass is there, velocity is in positive x direction. So how will be writing momentum? M into V I cap. What about this body? Mass into velocity, but this velocity is in negative direction. That's why you have to attach a negative sign as well with this momentum. And in which direction? Negative direction. Correct? Now see this question. What is the question? Newton's law is all about questions only. Two bodies having mass 6 kg and 9 kg are said to have equal momentum. Both the momentum of these bodies, PA is equal to momentum of PB. Okay. Equal momentum while in the motion. Find out the ratio of their velocities. You have to calculate what will be the ratio of their velocities. Momentum is given equal, so make it equal. What is the momentum of body A? You will be writing ma into velocity of A is equals to mb into velocity of B. And what you have to calculate? The ratio of their velocity. Ratio of their velocities. What you will be doing? VA divided by VB is equals to mv divided by ma. What is the mv or m2? That is 9. What is ma? That is 6. That means I can say it is nothing but going to be 3 by 2. Simple formula application. Correct? Is it clear now how to tackle momentum? What is momentum? Correct. Now see, Newton's second law says what? Why I have told you that Newton's first law and third law are similar. Second law is a little bit important because it gives you the relation of force is equal to mass into acceleration. But a lot of people where make mistake. That's why I have taken this separately. Reason is there. You people remember it directly as force is equal to mass into acceleration. A lot of students I have met and they said, sir, Newton's second law is force is equal to mass into acceleration. But it's not like that. What you have to understand that force is defined as rate of change of momentum. Force is defined as what? Rate of change of momentum. And when you will do it, what is momentum? It is mass into velocity. That means what you can further say, now differentiate it, apply product rule. That means m into dv by dt plus of v into dm by dt. Now the case that we most of the time that happens is dm by dt. That means mass doesn't change with time. Mass doesn't change with time. That means this value will become 0. This value will become 0 and this value will become mass into acceleration. This value will become mass into acceleration. That's why we most of the time we get force is equal to mass into acceleration. Correct? But it don't remember that Newton's second law is only force mass into acceleration. It is actually rate of change of momentum. Okay. See here. What is the next question? Momentum of a particle is given. Momentum of a particle is given with some relation. Momentum is given as 5t square I cap plus 10t j cap. Find the magnitude and direction of force acting on the particle at t is equals to 1. You have to calculate what will be the magnitude as well as direction of force at t is equals to 1. Okay, so let's calculate. How you can calculate force? Force is simply what? dp by dt. So can I say I should differentiate this equation? To differentiate this equation, you will have what? 10ti plus of 10j. At what time you want to calculate force? At t is equals to 1 you want to calculate force. When t is equal to 1 you will have 10i plus of 10j. 10i plus 10j. That means 10 Newton in positive x-axis and 10 Newton in positive y-axis. That means where you will get the resultant. Now is it clear that magnitude wise it will be 10 root 2 and the direction will be simply now. This is 10 j cap. This is 10 I cap. And the resultant will be coming exactly in between. That is 10 root 2 at an angle of 45 degree. Done? At an angle of 45 degree. That will be the solution. Fine. Unit of force, all of you are knowing it is Newton. Okay. Gravitational unit, how you define weight? Weight is defined as m into g. Always remember, a lot of time weight is given directly. Weight is defined in what? Kg. Kg is the unit for weight. So if weight is given, how you will be calculating your mass? Weight is equals to m into g. So whenever weight is given, don't get confused. Okay, that this is Newton. Newton's third law. Newton's third law says what? Every force have action reaction pair. Every force. Whenever you will be drawing a body, always there is an action reaction pair. Now in this one, if I will talk about where you will be making mistake, most of the students will may have a misconception that that for gravitational force that always act downwards. When you are standing here, let's suppose you are standing on the ground. That means you are applying some force on the ground, correct? Mg in downward direction, and the ground will apply some normal reaction on you. And a lot of people make a misconception that action reaction pair for mg force is normal, but that is completely wrong. That is not correct. For reaction pair of mg, there is an mg force that is acting from the center of earth. When you will be going into the complete depth of FBT, then where we draw. And for mg, there is a different reaction pair for mg as well. Okay, so don't get misconception that and normal is the reaction pair for mg. Not at all. Okay, it have a property that it will be same kind of force in opposite direction. Magnitude will as well be same. This is about system. Whenever you are solving questions, a lot of time it helps you in solving tackling questions. Okay, see what is the question. A question is there: a particle moving with velocity v is acted upon by three forces shown the vector triangle PQR. The velocity of the particle will, see, shown vector. Here are the three vectors that have been shown. So what will be the resultant? Firstly, you have to calculate the resultant of these three vectors. Calculate it. How you will be calculating? If we'll making this, here are the three vectors that you got. This is P, RP vector, this is QR vector, and this is PQ vector. If we'll calculate the resultant of all these vectors, can I say it is nothing but 0? If the resultant of force is equal to 0, that means can I say acceleration is also 0? And if acceleration is also 0, that means I can say simply what? That velocity will be constant, that we are watching from simply from the rectilinear motion itself. From the motion in 1D, we are watching this, that when acceleration is equal to 0, simply velocity will not never change. That means it is one more thing is clear, that whenever there is a force, there will be change in velocity as well. Is it clear? Because with force, acceleration will always be coming. Conservation of momentum. Conservation of momentum, that is also connected with it. How we do conserve momentum? What is the required condition for conservation of momentum? External force should be 0. External force should be 0. If external force is 0, we can say that initial momentum should be conserved. That means initial momentum is equal to final momentum. Why we say that? Because we define force is equal to rate of change of momentum with time. So can I say if external is 0, force external is 0, I can say delta P is also 0. That means delta P is what? Change in momentum. That means I can say P final minus of P initial is equal to 0. That means P initial is equal to P final. P initial is equal to P final. Correct? So that's why we call that momentum will be conserved. I hope that you know how to write momentum. A lot of good application questions are there from conservation of momentum. Okay, a lot of good application questions made. Let's suppose here a question is there. A body of mass 100 kg is moving horizontally with a velocity 1000 kg, sorry, with a velocity 50 meter per second. Okay. A mass of 250 kg is added suddenly. Find the final velocity. Let's suppose a mass of 250 kg is added on the given mass. Then what will be the final velocity? Let's see how we can calculate. We'll be doing what? There is no external force. No external force is added. External force means what? Any let's suppose I have applied a force. I have applied from hand. I have stopped anything. Nothing like that. No external force is added. I have just put it a block. Okay, that is what? Internal force. So I can say what? Initial momentum should be equal to final momentum. Is it clear? So how will I write initial momentum? Initially, what was the mass? What was the mass that was moving? Can you say 1000 kg into velocity? What was the initial velocity? 50. Correct? Initially, I can say only this is the momentum. Finally, what I can say, what is the total mass? Now I have added a 250 kg mass extra on it. So I can say what will be my new total mass? 1250. And what will be the velocity? That I don't know. I had to calculate. V final. Correct? So what will be this calculation is going to be? Calculate kar lo. This will be cancelled. Here, ye ho jayega. 25 here it will be coming. It will be how much? It will be 40. So final velocity, I can say after putting the block, this velocity will reduce to, initially it was moving with 50 meter per second. Now it will be moving with only 40 meter per second. Correct? How we have calculated? Using the conservation of momentum, because no external force was added here. Correct? So this kind of questions you can apply the conservation of momentum. Is it clear? Next one is impulse. There is a term always introduced, that is impulse. Impulse is what? Simply remember change in momentum. Change in momentum is defined as what? Impulse. What is the initial momentum? What is the final momentum? Just take the difference, you will be having your impulse. For example, let's suppose how you can define initially the ball. For the ball also you can have the same thing. Let's suppose this ball was moving. Okay, initially it have momentum, some velocity v1. Now you have made a kick to the ball. You have kicked the ball. That means you have applied some force on it. you applied some force, and finally after you're kicking, just the moment you kick, velocity will all of a sudden it will increase. What happened? Is there any lag? After you're kicking, just the moment you kick, velocity will all of a sudden it will increase. I think that it is fine. See, so the moment you will kick for a very small time, what you will say? I think so now it is clear. Okay. So impulse is just simply what? Change in momentum. Impulse is what? Simply change in momentum. Initially the ball was moving with a velocity v. Let's suppose the ball have mass m. Initially it was moving with some v initial. After your kick it will be moving with some v final. Just take the difference. That quantity will be defined as what? Impulse. That quantity is defined as what? Impulse. Okay. So it is in another way also it is defined as, and what is the representation, that also I will tell you. Representation for impulse is J. Okay, is J. One more way of question that can be asked, if ft curve is given, if ft curve is given, let's suppose force versus time curve is given, what you have to do, you have to check. Always I have told you in the last class, for any kind of curve, firstly you will ask yourself two questions simply. What are those two questions? First question you will ask that what is the slope, and second question you will ask what is the area under the curve. Here what will be the slope? Df by dt. Anything it is given considerable? No. Let's take the area under the curve. If I will take area under the curve, what I can say? Area under the curve. Area under the curve is y dx. Y. What is that y axis? This is force. And what is that x axis? It is time. So I can say what? F dt. It will be what? F dt. Force will be what? If you write the dimensions, mlt minus 2 into t. That means what I can net I am having, it is equals to mlt minus 1. So can you say it is the dimension of momentum? Yes or no? Mass into velocity, lt minus 1. So I can say that this area under the curve is going to give me the change in momentum, and the change in momentum, there is one more way for writing this j, that is equals to integration of f dot dt. So if any variables are there, a time variable, force equation is given to you, so how you will be calculating momentum? Just integrate it f dt from initial time to final time, you will be having your impulse. Or in simpler words, if I will say, just take the difference of momentum, initial momentum minus final momentum, you will be having your result. Okay, so both the ways I have told you how to calculate. If curve is given, then how? If not, then how? See here, a very common question that used to come, that is here mentioned. Let's see how to tackle this kind of questions. A 100-gram iron ball is mentioned, having a velocity 10 meter per second, collides with a wall at an angle of 30 degree and rebounds at the same angle. It hits the wall with an angle of, this angle is given as 30 degree. Okay, and this mass is 100 gram. Velocity is 10. Same angle. If the period of contact between the time and the wall, the period of contact that was here is 0.1 second, then the force experienced by the wall, what will be the force that will be experienced? Simply, if any time there is a relation between velocity, time and force, what is the relation that you know? Can you say simply, I know one single relation, that is force is equals to dp by dt. Force is equals to dp by dt. That means change in momentum with time. This is the relation that I know. So how I can write change in momentum? I will write p final minus of p initial divided by time. And time is already mentioned. Time is how much? 0.1 second. Time is already mentioned, that is 0.1 second. Now how do I can write that change in momentum? That is an interesting thing. Now see what happens. You will have here two components. Here you will have two components. Can you see this angle will be nothing but 60 degree, and this velocity is 10. So what will be this component? This will be 10 cos of 60. And what is cos of 60? It is 1 by 2. That means this velocity will be what? 5 meters per second. And this component will be what? Second component. Second component will be 10 sine of 60. That means 10 into root 3 by 2. Miss, can I say it is nothing but 5 root 3? Correct. This is one component of velocity. This is the second component of velocity, that means 5 meter per second. Now, can I say that this component is actually not going to hit the wall? If that component of the ball is not going to hit the wall, why there will be change in momentum? Change in momentum coming that time now when it is going to hit something or some impulse will be acting. So I can say this will be remain unaffected. Here it will be as it is same 5 root 3. Whatever the change will be coming, that will be coming only for the horizontal component. That will be only coming for the horizontal component. Correct. So, and it is actually getting hit at the same angle. That means I can say that it will be reflected back at the same value. That means the final velocity will also be same, and this time it will be in negative direction 5 meter per second, because it is given that it is rebound at the same angle. That means all the symmetry will be used below this and above this. Same kind of motion will be performed. So I can say what I can write for final momentum. I can write final momentum that is in negative direction. It can be written like this: minus of m into v final minus, and initially it is in positive direction, so I will write minus v in initial. Now the both side it will be negative value, so I will be taking that common, and mass I will be taking common. Now just add both of these values. It will be 5 plus 5 divided by 0.1, and here mass is also how much? It can also be written as 0.1. That means I can say it is nothing but equals to 10. Force will be equals to 10 Newton. After calculation, simply you'll be getting the answer. Is it clear how we are getting? So this is the way you have to understand that the component of velocity that is going to hit the wall, that is only going to change because it is the actual component that is going to collision. When you understand the collision case also, so there you will have the more idea. In collision case, this kind of questions we used to solve. Okay, but here also without collision concept knowing, you can also solve, because the condition was already given that it rebounds at the same angle. Okay. Now about equilibrium, let's understand a little bit about equilibrium. What is the equilibrium? Equilibrium simply means whenever it is the condition of equilibrium given into the question, that means every single thing at rest, net force acting on the system, that is equals to 0. That is what the condition of equilibrium. In all the direction. Now any way possible you have to create the condition of equilibrium, and it helps to solve a lot of questions, actually. Okay, let's understand how these questions are going to help. Okay, this concept is going to help. See, there are a lot of varieties of questions. Now we are going to tackle from here. We will be drawing the FBDs, and I will be telling you to solve how you can write the equation. These are very general questions, very standard questions. See, first question. Two blocks are kept in contact, experience 100 Newton forces experience. Find the acceleration of 5 kg block and the normal force between the blocks. Now see, what is the system? Two blocks problem is there. One is 5 kg, one is 20 kg, and 100 Newton force is applied on block A. You have to calculate two things. What is the acceleration of A? And second thing, what will be the normal contact force that is applied in between? Okay, so now understand here how you can solve. First step, always in this kind of questions, assume it as a system. What is the meaning of system? That means you will understand that it is not two blocks. Now it is only one block of mass 25 kg and 100 Newton force you have applied. That is, can I calculate the acceleration? Of course, both of them are going to move with the same acceleration together. So what I can say about the system, net force is equals to mass into acceleration, and if I have to calculate acceleration, I will be simply writing the net force that is applied 100 divided by 25. That means I can say acceleration is nothing but equals to 4 meter per second square. This one is clear. Fine. Now come to the next portion. How we can calculate the normal contact force in between them. So for that we have to draw the FBD separately for both the blocks. Draw the FBD properly. This is body A, that is of 5 kg. This is body B, that is of 20 kg. Correct. Now you have to understand what will be the forces on 5 kg. Obviously there will be some mg also, there will be some normal also, but they are not relevant to this question because the motion is happening in the x-axis. So that it's your choice if you want to replicate that. What will be this force? This force you have applied in 100 Newton, and in front of 5 kg there is 20 Newton who will be trying to stop this Correct. If it is trying to stop this, can you say normal reaction on block A due to B will be in negative direction? Yes or no? If you understood this, this question is nothing. And action reaction pair says that if this is applied in a negative direction, that means some force by A that is pushing. Of course, that is who will be taking this B in forward action. Can you say this normal reaction on B due to A action reaction pair equal in magnitude, opposite in direction? अरे हाँ या ना समझ आया ठीक है now just write the equations both of the bodies I can say moving with acceleration 4 both the bodies are moving with acceleration 4 अब किसी पे भी इक्वेशन लिख लो let's suppose you want to write the equation on this one you'll be writing net force is equals to mass into acceleration. What is the net force? You will say net force that is applied here is normal reaction is equals to mass that is 20 and acceleration is equals to 4. That means how much force is there? 80 Newton. If you are applying the equation on block A also, then also you will be having the same answer. There will be nothing difference that will be observing. Is it clear? It was a good application question. So you should be able to solve these kind of questions. Simply answer acceleration 4 and normal 80. Answers are still, I will say, not important. How we have solved, that is important. Now, second very important case about the tension. Let's suppose 2-3 bodies are connected by a string. How to solve these kind of questions? A lot of fear you had. Let's tackle this also. We'll understand by a question. Again, the same kind of method I am going to follow. See, firstly, I am going to draw the ABD. They will be asking you about the find the tension in the string connecting the 3 bodies. There will be tension, and you know this property that same string will have same tension. Same string will have same tension. So firstly, what you will be doing, assume it as a system. If you are assuming this as a system, what I can say, there are not 3 bodies, there is only single body. If there is a single body, what you can say about acceleration? Acceleration can be said as 20 Newton, that is the net force divided by the total mass. 8 by 10, that means I can say the net acceleration is equal to 2 meter per second square. Correct? This is the. Now come to the FBD. I am drawing the FBD very properly. Please understand the importance of FBDs. What happened? Let's draw the FBD. This is your 5 kg. This is your 5 kg. This is your 3 kg. And this is your 2 kg. Correct? यार आजा भाई क्यों कर रहा है why this is happening? Let's see from this itself. Let's suppose this is 5 kg. Let's suppose this is 5 kg. What I can say about 2 kg? Here it is applied a 20 Newton force in forward direction. 20 Newton force that is already mentioned here. That is applied in forward direction. Now what about this one? Can you say here a tension will be applied in backward direction? Let's suppose name this tension T1. Because tension is what? Always acting away from the body. If this is tension T1, what will be happening on 3 kg? 3 kg is also moving ahead with what acceleration? 2. That means who is taking this in forward action? Can you say action reaction pair of T1 will be applied here? Correct? Newton's third law. Now what about this? This is a different wire. That means it will have a different tension away from the body. It will, let's suppose it is having some tension T2, and action reaction pair who is taking this body A in forward action, that is, let's suppose, tension 2. That means acceleration I have calculated, and now what else I have to calculate? I have to calculate this T1 and I have to calculate this T2 as well. So let's understand how to calculate. Now just write the equations. You will be having all the things. Let's suppose I am writing the equation on body on mass 2. On mass 2 I am writing this equation. Mass 2, if I will say, what is the forward direction in positive x direction? What is the force? 20 Newton. In backward direction, what is the force? T1. What is the acceleration in forward direction? That is 2 meter per second square. Tell me, what is the net force? In the direction of motion, always we write the net force. Who will be greater? If acceleration is in forward direction, I am telling you how to write the equations from the complete basics. Please try to understand. If a body is moving in forward direction, what I can say? Which force component is greater? Can I say 20 Newton? So what will be saying that 20 minus T, it is the net force is equals to mass, that is 2, into acceleration, that is again 2. So from here, can you say you got your tension T1? I should mention it as T1. correct? So how much you will get? T1, take it here, and I can say it is equals to 16 Newton. I can say it is equals to 16 Newton, correct? For T2, if you want to calculate from T2, you can do simply two things. Either write the equation on body 3 kg, either write the equation on 5 kg. Both of them is going to give you the answer. Let's suppose if you want to write the equation on 5 kg, I'll be writing this is what T2. What is the acceleration? Acceleration will be same, that is 2 meter per second square. So what is the net force? Only single force, that is T2 is equals to mass into acceleration, that is 5 into 2. That means answer will be how much? 10 Newton. So first answer is how much? 16 Newton. Second answer is how much? 10 Newton. Is it clear? Someone, any doubt? If still any doubt, please comment down. One answer will be 16, one answer will be 10 Newton. Correct? Now let's suppose you are having at inclined planes. Inclined planes, one question we have seen. Inclined planes, just simple remember one thing, how to take the components. That is only the major thing that we'll be having. Other than that, rest of the things you can easily understand. Normally what is the FBT that we are going to draw is, I'm going to draw this component. Oh, no, it is working. I'm going to draw this component as mg in downward direction. If this is mg, this will be what? This will be 90 minus theta. So when you will be taking this component along the surface, two components always you have to take. Along the component, it will be mg cos of 90 minus theta. That means directly I can say that it is equals to mg sine of theta. And perpendicular to the surface, it will be coming mg cos of theta. And you have to always mention that is normal is always in the opposite direction, perpendicular to the surface. Correct? This much you should be knowing about the inclined plane to draw the FBT always. That is the first thing that you will always be doing in FBTs. Okay. Now let's see here what you can do. Figure shows 3 blocks connected by a light inextensible string. A pulling force of 100 Newton is applied on the block of 2 kg horizontally. Find the ratio of the tensions in the string connecting the 3 blocks. Now again same kind of question is there. This time you just have to calculate what will be the tensions again. Okay, can you do this? What will be the process I will be telling, and then you will be solving it. What is the first step? You will be assuming this as a system. When you will be assuming this as a system, can you say this is not 3 blocks now, this is a single block of mass how much? 2 plus 3, that is 5, and it is 10. Okay, 10, and here it is force is applied 100. Is there any other force also? Last case it was not, because in the direction of motion perpendicular, the gravitation force was perpendicular, but this time gravitation force will also have some role. What will be the gravitation force net you can draw? This will be mg, but it will have some component along the along the motion. That component will be 10 into g, that is 100, and this angle is 53. Now what is sine of 53? Sine of 53 is 4 by 5, 20. That means this force is nothing but 80 Newton. This force is 80 Newton. That is what you can say about the acceleration. Acceleration पहले तो लिख लो पूरे system का. Acceleration you will be writing 100 minus of 80 divided by the mass. That means can you say acceleration will be again coming to be 2 meter per second square. Acceleration will be again coming, that is equals to 2 meter per second square. After that what you will be doing? Now draw the FBT for this 2 kg only. For this 2 kg, what will be saying? This will be your T1. This will be your T1. Along with that, you will have one more component along the same direction, that will be 2g sine of 53 degree. How much the component will be coming? 2g sine of 63 degree. Both will be in the same direction. Now you will be calculating from there what will be the acceleration. Net force, how will be writing? Net force you will be writing. Let's suppose assume that the complete system is moving in for upward direction, that means 100 minus of 2g sine 53 plus of t1. One equation, if you will ask me, then I will write for 2 kg. 2 kg, I will write the equation. You will be writing 100 minus of t1 minus of 2g, that means 20, sine of 53, that means 4 by 5. It is equals to mass into acceleration, that means 2 into 2. When you will solve it, solve भी कर लो, मेरे से ही पूरा करवा लिया. So it will become how much? This is also 4. Here it will become 8. 100 this is minus of T1. That means T1, if I am not wrong, this is going to be equals to 92 Newton. Yeah, yes or no? T1, it is going there. This is actually 16. Sorry, this is 16 minus 16. That means here it will become 20. It will become 20. That means it will become 80 Newton. It will become somewhere 80 Newton. Correct? Newton T1, correct answer. Then you'll be calculating same way T2. You'll be writing the equation same way on T2. Action reaction pair for T1, and in downward action there will be mg. Clear? In vertical motion, let's suppose any body is moving in vertical motion, then how you'll be writing the equation? Okay, nothing will be changed. Just simply understand how you'll be writing. Let's analyze all the three cases. Same kind of cases are for lift also. For lift also same kind of cases will be there. From this only single one you can relate. In upward direction, let's suppose this kind of system is there. How will be writing? Acceleration is, let's suppose, y. M1 and M2 are there. So firstly, if you want to calculate what is the acceleration, assume it as a system. How you can calculate acceleration? That is net force is equals to F, and what will be the masses? M1 plus M2. And then just write single in the equation for this body M1. How will be writing the equation? This will be what? M1g, and the same direction it will be what? T. And let's suppose if it is going in upward direction, that means a greater force will be what? F. That means what will be writing? F minus of T minus of M1g is equals to M1 into A. This is the first equation. Correct? This way you can write for M2 as well. Equation लिखने आ रहा है. Writing equations is the most important thing. Now take for the second one. Okay, for the same thing, it is written the equation here. Let's suppose here tension will be applied in upward direction. Action reaction pair, if here it is in away direction, always it is away in the acting in the away direction, and here in downward direction it is M2. The net acceleration is in positive direction. How will be writing the equation? If the net body is going in upward direction, who is greater? Tension is greater. How will be writing the equation? T minus M2g is equals to M2 into A. Simply this will be the equation. So tension can also be written as M2 as common A plus G, or also it is called as G effective. This is also given a term of G effective. What is the effective gravitation or the value of G? Second one I have already told you, there I have written the equation already. समझ आया how to write the equation? Any kind of condition it is given, yeah. Just follow the simple method, draw the FBD properly, and be confident in writing the equations. Until unless you are not confident in writing equations, मजा नहीं आने वाला यार. You will not enjoy laws of motion. Next question. Can you solve it now? Can you solve it? Now I will give you this as a homework. Same way just you have did for the last one. चलो यार FBD बना देता हूँ. FBD I will draw. Rest of the question you will solve, and please comment down in the comment section. Okay, let's see how many of you can solve. Here this kind of scenario is given. This is 1.5 kg. Then second mass again 1.5 kg. Third mass, that is 4 kg. कैसे बनाओगे FBD? This will be what? 4g. This will be what? T3 is mentioned in this wire, so we'll be mentioning here T3 in upward direction. For 1.5g, how will be drawing? This will be action reaction pair T3, and obviously it will have 1.5g, that is the gravitation force acting in downward direction, and this wire is named as T2. So this will be the component of FBD of wire, this body 2. Then action reaction pair T2 is in downward direction. Obviously there will be 1.5g, that is the gravitation force, and here in this wire the tension named is T1. I've drawn the FBD for the complete system. Now just apply. Firstly, we'll be calculating the acceleration, taking it as a system, and then apply the equation of all the bodies. Correct? Kar loge? Very good. Nearly all the varieties we are covered. Now pulley system will only be left. Pulley. Now pulley have some interesting cases that majorly 3 to 4 cases are there. 4 cases I will say. All the cases you will be easily able to solve. Just focus here in the class. Listen. the most simple one is given here. Okay, there is a direct formula also. Tell me if anyone know about this direct formula of this string pulley system. See, what is the one? In downward direction, it will be 3G. How to solve this question? I am telling you. Downward direction 3G, it will be tension. And always remember, if it is the same string, that means tension will always be same away from the body. This will be what? 2G. Correct? Equation is right. Equation. Assume anyone that, let's suppose if it is heavier, that this body is going in acceleration with a downward direction. Some acceleration, that means same acceleration, it is going in upward direction. Obviously, it is a pulley. That means one will be going downward, that means second one will be coming upward with the same acceleration. Now write the equation on both the bodies. And the second one, if you are writing the equation, how you can write the equation. Second one, the net body 3 kg is going in downward direction. That means who will be greater, tension or 3G? Can I say 3G will be greater? So write 3G minus of tension is equals to 3 into A. Second body, what you can write, that tension is greater, T minus of 2G is equals to 2 into A. Now how you have to solve these two equations? How you can solve? Just add both these equations. Adding both these equations, TT cancel. TT cancel, what will be left? Here it will be G is equals to 5A. Adding, that means acceleration, I can say how much it is going to come? G by 5. G by 5, the acceleration will be coming. If you want to calculate tension, so tension we calculate kar lo. Tension, if you want to calculate, make it 3G minus of 3A. A can be written as G by 5. That means net it can be written as 15. That means 12G by 5. Tension will be calculated as 12G by 5. These are the two things that you always have to calculate. There is a direct formula. What is the direct formula? Acceleration, it is equals to m2 minus m1 g divided by m1 plus m2. This is the formula for acceleration. Put karo, m2 minus m1, that is 1 g divided by m1 plus m2, that means can I say it is equals to g by 5. और tension के लिए क्या formula है? Tension is equals to 2 m1 m2 g divided by m1 plus m2. Now see, 2 times of m1 m2. m1 m2, it will be 6. Can I say 6 into 12? 12g divided by 5. 12g divided by 5, that will be your tension. That is a direct formula that you can remember. You should remember for the simple spring pulley system, the first case that you will be having. Okay. Now see, this was the case 1. I am going to cover all the cases. Let's see one by one. This was the first case for spring pulley system. Case 2. What kind of scenario you can have? I will discuss all those scenarios. This kind of cases can be the case 2. Let's suppose here is a body M2. In general, I am talking about now. Here is a body M1, and I will say, let's suppose M2 is greater than M1. This is case 2. How will be drawing? What we will be doing? How will be writing the equation? Understand. Now see, let's suppose M2 is greater than M1. That means what I can say? This body M2 is going in downward direction. Let's suppose having some acceleration A. With the same acceleration, this body will be going in the forward direction. Correct? Now write the equations. Draw the APD. This will be what? M2G. This will be what? Tension. Connected with the same string, this will be tension. And M1G will be in the perpendicular direction. That's why it is not going to affect this motion. So you are drawing it or not, it is not going to affect. Write the equations. How will be writing the equations? For this body, it is going in downward direction. That means I will say who is greater? M2G is greater. Minus of tension is equals to M2 into A. This is for body 2. For body 1, how I will be writing the equation? I will write simply tension is a single force who is responsible for taking it ahead. That means tension is equals to M1 into A. Solve kar lo. 2 equation, 2 variable, tension and acceleration. Easily you can get your answer. Correct? This is the case 2. Move to case 3. What is case 3? Case 3 is you can have like this. Let's suppose case 3 is that some angle. Let's suppose you are having at some angle, or this kind of diagram also you can have. Let's remove this. Let's suppose this kind of some system is given. Inclined plane is there. Some angle theta is given. Here is a pulley connected. Here is a mass connected M1, and here it is connected some mass M2, and again it is mentioned that M2 is greater than M1. आप क्या करोगे? How will be tackling? Just simply draw the ABD, nothing else, nothing else. Simply draw the ABD. What will be the ABD? This will be what? M1G, always acting downwards. This component of force will be what? M1G sine of theta, because it is going to come along the motion. I can say this will be tension connected with the same thing. This will also be tension, and this will be what? M2G. Correct? Now let's solve this question. Write the equation. I assume that anyone is going downward. If you are having wrong assumptions, simply you will have a negative sign. That's it. If it is going in downward direction with acceleration, this is going to move with the along the incline with acceleration A. Solve it. Which one will be greater, tension or M1G sine theta? I will say simply for this body M1, this will be tension will be greater. M1G sine of theta is equals to mass into acceleration. For second body, how I will be writing the equation? M2G, that is because this is the greater force, because it is going in downward direction according to our assumptions, minus of T is equals to M2 into A. This is the first equation. This is the second equation. Question solved. Question solved. Is it clear? समझ में आ रहा? So, and the final case will be, now you can draw by yourself. You can solve it by yourself. This is the final case. Let's suppose both sides you have inclined. कुछ नहीं, FBD बनाओ. Nothing else. This is M1. This is M2. Let's suppose this angle is some alpha. This angle is some beta. Again, you will be writing the equation, two equations on the two bodies, and again you will be solving the question. Clear है? समझ में आया? कुछ नहीं, FBD बनाना. Okay, and just write the equation and tell me in the comment section. I will be checking that equation if you will make it correct or not. Okay, so fine. These were the major cases for spring pulley system that I had to discuss and I had discussed. Okay, now there is a concept of weighing machine. That from where you measures your weight, that is what your weighing machine is. Okay, see, important point about weighing machine is weighing machine measures the body weight. Then in both the cases it should be okay, got it. So weighing machine is actually measures the normal force. Weighing machine is what doing? It is measuring the normal force that you will be having. Okay, so that's why when you put yourself on the weighing machine, it is giving you the complete force reading that you will be having there. Okay, so sometime a question also can be come from weighing machine. You have to draw the FBD properly. Sometimes also can be a question that weighing machine is kept in a lift and the lift is moving upward or downward. That kind of question also you have to tackle. Okay, what kind of questions you will be having from lift, I would have to tell you. See, here only I will tell you. Let's suppose what kind of questions you will have. There is a lift and here is a weighing machine, and now this weighing machine, let's suppose a body is kept of 2 kg and this weighing machine is moving upward with acceleration A. Now you have to solve this question. How will be solving? You have to draw the FBD. This weighing machine will have, this 2 kg will have a force in downward direction and this weighing machine will give you a normal reaction, correct? So how will be writing the equation? And this complete system is moving in upward direction. So how will be writing? Normal minus mg is equals to m into a. This will be the equation that will be writing. And how will be calculating the reading? N is equals to ma plus mg. That is the normal reaction that we will be having. Correct? So lift questions you should be able just watch the direction of the lift and that's it. You can solve it from there. Okay. Now next one is about, in little bit you have to understand about inertial frame and non-inertial frame. What is inertial frame? Inertial frame, that means the frame of reference that you are talking about is either at rest or either it is moving with some constant velocity. Either it is moving with some constant velocity. Net meaning is what? That acceleration should be zero. Acceleration should be zero of what? The reference point that you are taking. Okay, what is the definition? Inertial frame of reference is a frame where Newton's holds law true. An inertial frame is at rest, moves with a constant velocity with respect to assumed inertial frame of reference. Acceleration of the frame should be zero, or either it can be moving with, either it is standing at rest. That kind of scenarios are called as inertial frame. There is a concept of pseudo force that was introduced in non-inertial frame. अगर तुम्हें याद होगा, non-inertial frame means what? Simply if the frame of reference is having some acceleration, then it is called as non-inertial frame. Okay, for example, if a person is sitting in the car and it is moving with some acceleration, obviously it is in non-inertial frame. Okay. And whenever there is a case of non-inertial frame, there is a concept of pseudo force. There is a concept of pseudo force. What is pseudo force? Pseudo force, if I will talk about the magnitude wise, if you want to apply pseudo force, it is mass into acceleration of the non-inertial frame, and the direction is always opposite to the motion. Okay. For example, let's suppose you have to apply pseudo force. Here, what you can write? See, a body person is there again, that weighing machine case have been there, the normal reaction that have been measured here. Let's suppose here it is the case, that means this according to this person, can you say this person is in non-inertial because it is accelerating in upward direction, and in the second case it is accelerating in downward direction. So how you will be applying that normal reaction, pseudo force? If you want to solve this by pseudo force, how you can solve? With respect to this person, this is a non-inertial frame, that means there will be some pseudo force will be acting. Suppose this is body M. Simply two forces you already know, that this will be the normal force, this will be what? Mg force. Now you want to apply pseudo force. Otherwise without pseudo force also you can solve this, but still, let's suppose you want to apply pseudo force. What I have told you, pseudo force is equals to mass into acceleration in the opposite direction of the motion. That means I can say it will be pseudo force will be acting in the opposite direction. Pseudo force, anyways, it is represented by Pseudo. Okay, but still I am writing as it is equals to mass into acceleration of non-inertial frame, that is equals to A. Right? Now I can say with respect to the person it is at rest, that means it will be a case of equilibrium. N is equals to mg plus of mn. That is what I can say about n. N is equals to m common g plus A. N is equals to mg plus A. Clear? And same can be going for the second case. Otherwise, if you're not like this, then you can write the equation in other way. You'll be not applying the pseudo force, you'll be simply here writing acceleration A, and how you'll be writing the equation? N minus mg is equals to ma, and then you have written that n is equals to mg plus ma. Result will be coming same. Okay. But sometimes for solving purpose, you can take the reference of a non-inertial frame. In non-inertial frame, you can apply that pseudo force. Is it clear? Here also you can apply the pseudo force in non-inertial frame. If you are imagining that you are sitting in the vehicle, so you can apply, but without pseudo force also you can solve this question. Just when it is moving in ahead direction, in forward direction, this body will have a feeling a tension in it will be moving in the backward direction. Obviously, whenever you're sitting in a car and your body is accelerating, you will feeling a force in backward direction. Correct? Just maintain the equilibrium that will be present here, and simply you can draw the ABD and just take the ratio. You'll be having the answer. Without pseudo force also you can solve it, and no need for desperately entering into the pseudo concept. Okay. If our work is done without pseudo concept, then what is the problem? Okay. Now let's come to the section of friction. That is also extended portion of laws of motion, that if you know how to draw the ABDs, then you should also know about friction as well. Friction is a very interesting thing. Okay. So how it applies, I've already told you. Friction have normal tendency. If you want to move, I will oppose you. If you want to move in any direction, even if you think to move in any direction, I am going to oppose it. That is what the work of friction simply. Okay. Now there are a variety of friction. Let's understand one by one. First one is static friction. Static friction always apply from the name itself. It is very clear. Whenever body is at rest, which kind of friction will be applied? Static friction. कोई doubt नहीं रखना है. Simple दिमाग में clear. Static friction means what? Whenever a body is at rest, it will apply static friction. Now let's understand what is static friction. Let's suppose you are applying some force 5 Newton in forward direction. Okay, and sufficient friction is available. So what will be happening? Static friction will be applied 5 Newton. Correct. Let's suppose maximum capacity, we will come to the maximum capacity also. That means what will happen? Now the acceleration will be 0. That means body will not move. Let's suppose you have applied 10 Newton and you have the capability of 10 Newton. That means friction will be applied 10 Newton. It is variable. Okay. It is used according to the need. Let's suppose you have the capacity, you are applying 15 Newton and I have the capacity of friction that is equals to 15 Newton. So 15 Newton will be applied and body will not going to move. Correct. So the maximum value of static friction, that can be applied to stop the body is defined as limiting friction. So don't get confused. Static friction and limiting friction is what? Limiting friction is the maximum value of static friction until what that friction can be. Let's understand with a simple example. Should we understand? Let's see. Let's suppose a body is there. Okay. Let's suppose I am taking any random values, 5 kg and mu s. I hope that this mu also you know, and friction, how friction can be written as, friction is defined as mu into n. For static friction, you will be writing mu s into n. N is what? The normal reaction. This will be clear, I hope. Let's suppose mu s is given as 2. Can you tell me what will be the friction that can be applied? Friction can be applied as mu, that is equals to 0.2 into n. N is how much? Normal reaction will be 50, obviously. So it will be 10 Newton. 10 Newton of friction, static friction. I am talking about static friction that can be applied. Correct? Now let's see different cases. Different cases. Let's suppose first time I have applied force that is equals to 1 Newton. But body will be moving or not? Body will be moving or not? No. Why? Because in opposite direction I will apply a 1 Newton force, friction force. Let's suppose I have applied 5 Newton. Let's suppose I have applied 5 Newton. Then what will happen? Still body will not move because friction have the ability to apply 5 Newton in the opposite direction. Still there is no movement. Let's suppose I have applied 10 Newton. Till 10 Newton, still it will not be moving because now the limiting friction will be coming into use. That is the maximum friction will be applied now. Now, if you increase this, the moment 10.1 Newton, the body will start moving because you have crossed the maximum limit or the limiting friction of static friction. I mean, that means you have crossed the limiting friction, I will say, because limiting friction is what the maximum value of static friction that can be applied. So the moment you will apply here 10.1 Newton also, the body will start moving in the forward direction. Is it clear? Now let's understand. So that when, let's suppose the body started moving, then static friction is not applicable. Then limiting friction is not in the scenario. Then there is a different friction, that is the second type of friction, that is called as kinetic friction. Kinetic friction is now, is it clear? Whenever a body is moving, then you will be having a kinetic friction. That is not a static friction. Okay. See. See here. What will be the value of limiting friction for a block of mass 5 kg kept on a flat surface? Mu s is also given. If a force 10 Newton is applied on the block, will it move? Firstly, we have to calculate what is the static friction. How much static friction is available? 0.4, that is mu, into n. N will be how much? 50. That will be equals to 20 Newton. That means I can say the maximum value of friction can be applied is 20 Newton. And how much force you are applying? 10 Newton. Never going to move. Why? Because I have the ability. I will apply simply friction in the opposite direction, that is equals to 10 Newton. Till 20 Newton, this body is never going to move anywhere. But the moment you are increasing the force more than 20, then it will obviously going to move. Correct? So there are, and of course, when the moment the body will start moving, this static friction will be reduced to the kinetic friction. Then kinetic friction will be coming into the scenario, and kinetic friction will have different value. How to write kinetic friction? It is equals to mu k into n. It is equals to mu k into n, and always kinetic friction is less than the static friction. This is a relation. There is a curve also. The very important curve is there that you have to remember. Not remember, that is very logical. I will tell you also. See, let's suppose take this question. A force of 50 Newton is applied on a block of 5 kg. Shown in the figure, find the frictional force and the acceleration of the block. You have to calculate what will be the frictional force and what will be the acceleration of the block. These kind of values will be given. Now be careful into this. Don't make normal reaction always equals to mg. That's why these are the points where you are probably making mistake. What you have to do, understand. You have to take two components of this force. First component, that will be what? This angle is 30, that means this angle is also 30. 50 cos of 30. That means what I can say? This force will be what? 50 root 3 by 2. That means in forward direction, what is the force that you will be having? 25 root 3. And in in downward direction, how much force is there? Here it will be 50 by 2. That means I can say 25 Newton. And I can say already 50 Newton is there. And I can say this will be the normal. So पहले तो ये बताओ कि normal कितना होगा? Can I say normal is equals to 25 plus of 50, that is equals to 75 Newton. That is equals to 75 Newton. First thing. Now calculate both the values. Friction, static friction. How much static friction is present? 0.4 into normal, that is 75, not 50, not 50. Correct? That means calculated कितना होगा ये? 75 into 4, 7 4 28. I guess that it will be 30 Newton. And kinetic friction 0.2, 0.2 into 75. That means it is equals to 15 Newton. Correct? Now understand what will be happening. The force that you are applying in forward action is 25 root 3. Can you say it is greater than 30 Newton? Obviously, yeah, it is going to be greater. Root 3 is nearly 1.7. Okay, exact value I am not clear about, but it is nearly 1.7 if I am not wrong. Okay, so I can say this is going to move, and if it is going to move, what I can say about the acceleration? Acceleration will be, that is 25 root 3 in forward direction minus in backward direction. Tell me, can you say now it have cleared the cutoff, that is equals to 30 Newton? That means it is going to move. But if it is going to move, that means static friction will not be applied. Then who will be applied? Kinetic friction. If kinetic friction is applied, it will be applied how much? 15 Newton divided by the mass, that is 5 kg. It will be our acceleration. And which friction is acting? 15 Newton force of friction is acting here. Now you can calculate in the numerical terms, and you can check what is the exact value will be coming. Here you can see that kinetic friction is 15 Newton, that we have already calculated. And acceleration, when you will be solving that root 3 value, then you will be having this value. You can cross check it, that is equals to 5.7 meter per second square. समझ में आया? Okay. So now here it is the graph of friction that I was talking about. Understand this graph. What is the meaning of this graph? I will tell you. Initially, if the applied force is 0, there is no friction will be applied. Okay, the moment this x-axis it is applied force, and on the y-axis it is a friction. Now slowly you are increasing the applied force. You are increasing the applied force value. Friction will also be increasing. Applied force increasing, and at a certain time it will be applied maximum, and that friction is called as what? Limiting friction. That friction is called as what? Limiting friction. The moment you will increase little bit above that, what will happen? All of a sudden the value will decrease. It is a lot broader shown here, but all of the sudden this value will be decreased, and it will be less than the static friction, and now it will start moving with a kinetic friction. Now it will start moving with a kinetic friction that will be always constant. Now it doesn't matter that how much force you want to apply, 10 Newton, 1000 Newton, 1000 Newton. In kinetic friction, one start body moves, that means now it is a constant friction, repulsive force that will be applied. Kinetic friction, that will be constant. That is not never going to be changed. Clear? So see this question, how you can solve. देखो क्या question. The block of mass 2 kg is placed in a fixed inclined plane as shown in the figure. The angle of inclination of the plane, okay. Find the minimum value of f so that the block doesn't move. You have to calculate what will be the minimum value of f so that the block doesn't going to move. Okay, block you don't want to move. That means every force should be equal to each other. That means it is a case of equilibrium. Case of equilibrium. So draw the FBD. Then let's see what can be done. This is the incline. This is the 2 kg block. Draw the neat FBD. Question will be solved in this only. See, this force downward direction, what will be this force? 20 Newton first thing. Correct? Mu is already given. Okay. Now, what will be this force? 30 degree it is, na? 30 degree, that means this will be 2g cos of 30. Cos of 30 is what? Root 3 by 2. Cos of 30 is root 3 by 2. That means how much this will be? 20 root under 3. But that means I can say this is nothing but equals to 10 root 3. Along the component, what will be there? 20 sine of 30. That means I can say this force is nothing but 10 Newton. Correct? And from this direction, of course, there will be some normal also. And in this direction, you are applying some force F, external force F you are applying. Correct? That means tell me what is the tendency of this body to move? Because tendency of the motion is important for applying friction force. What do you think? Where this body wants to move? In upward direction or in downward direction? Of course, in downward direction. If it is having the tendency to move in downward direction, that means our friction will be acting at the same moment you have thought about motion. I will oppose it. Friction is applied in opposite direction. Correct? So can I say to stop this body, friction, whatever friction will be there, have to be equals to 10 Newton. Correct? If these two will be equal, of course this body is never going to move anywhere. And how I can write friction? Friction can be written as mu into n. Mu is value is how much? 1 by 2 root 3 into normal. Now normal is how you'll be writing. Normal you'll be writing, it should be equals to f plus of 10 root 3. So write it. It will be equals to f plus of 10 root 3, that is equals to 10. This is the equation that you have to solve. Now here it will become how much? Force will be equals to, multiply it here, it will be 20 root 3 minus of 10 root 3, that means force is equals to 10 root 3 Newton. This will be the answer. How much force you have to apply? You have to apply 10 Newton force in that. You have to press it like it is like a pressing force. You have to press that block to stop this block from moving. Is it clear? Someone may add 10 root 3 will be the force. Correct? Now there are some values. What is angle of repose term? Let's suppose if it is introduced in the question, then what you have to interpret from here? Simply understand. Angle of repose is the angle. It is a maximum angle till which body will not going to slip down. Let's suppose initially a body was at flat one, not going to move anywhere. But let's suppose you have started increasing this angle. So it is the maximum angle till which the body is not going to move. So if you have to want to calculate this, that means I can say again the same kind of case. Can I say that means you want to make friction, this will be friction, this will be mg sin theta, you want to equate it basically. So I can say that you basically want that friction should be equal to mg sin theta. And what is this maximum value? Friction can be written as mu into n. N is what? Mg cos of theta is equals to mg sin of theta. So can I say mg cancel? Mu will be equal to tan of theta. And what I can say about theta? Theta is equals to tan inverse. So remember the value. If sometime angle of repose is there, it is nothing but they want to tell you about what? Mu. They will not directly give you mu, they will give you in some other ways. So you should be able to understand what is the value. Okay. Here, let's understand what will be the case. For the given arrangement, find the minimum value of mass m1. Minimum value of mass m1 for which the system remains in equilibrium. Assume the pulley and the string to be massless. You have to calculate what will the mass of m1 so that this complete system is going to be in equilibrium. Okay. Let's understand. Firstly, draw the FBD. FBD is the soul of the complete concept. FBD. What will be this force? M2G. Correct? What will be this force? Tension. What will be this force? Tension. What will be this force? M1G. What will be this force? Normal. And if there is mu, that means tendency of motion is in forward action. So I will say this is what? Friction. Correct? So if I am saying that the complete scenario is in equilibrium, that means nothing is moving. That means all the forces, net force in upward action is equal to net force in downward action. I can say all the forces are going to be equal. So from here, what I can say that tension is equals to M2G. Can I say it is the first equation? Because if I don't want to make the motion, I can say both of the forces are equal. So I can say this force tension is also equals to M2G. Now what will be the case? Understand. If body doesn't want to move, that means can I say again M2G wants to be equal to the friction. Correct? Now how you can write friction? Friction can be written as mu into n. N can be written as M1G is equals to friction. I have written it is equals to M2G. So what is the maximum value of M1 that you want to write? It is equals to M2G divided by mu into G cancel. It is equals to mu M2 divided by mu. That will be the value of M1. That means the more value you will decrease this for mu, the more M1 will be needed. Is it clear? Simply I am writing the equations and nothing else. Correct? Now for the given system, evaluate the acceleration of the system. You want to calculate the acceleration. What will be the acceleration of the system? And this time mu value is also available. So how you can do? One way is to take one body and then draw the FBD. But better way, if I will tell you, assume this as a system. Assume this as a system. So system will be looking like now this. Single body here, 2m mass, and a body is यहाँ से लटक रहा है. ठीक है? You want to calculate acceleration. Let's suppose this body is going to move in downward direction with some acceleration a. This is going to move it in forward direction with some acceleration a. Draw the FBD. When you will drawing the FBD, what you will be doing? Mention the forces. This will be mg, this will be tension, this will be tension, this will be the friction, that is equals to mu into n. Can write on the equation on the body 1. If you are writing equation on body 1, what you'll be writing? Mg minus of tension is equals to m into a. Correct? On body 2, when you will be writing the equation, what you will be writing? You will be writing T minus of friction. Friction is equal to mu into n. Mu into, that means you will be writing 2 mg. Will the normal is equals to 2m into a. Now if you want to solve it, add both these equations. Adding both these equations is going to give you what? Tension, tension cancel. Here it will be what? 2 mg mu plus of mg, sorry, here it will be minus sign, and here it will be what? 3 ma. M cancel. Here it is left what? Acceleration net you want to calculate, that means it will be g minus of 2 mu g divided by 3. That means take g common, you have taken 1 minus 2 mu divided by 3. Answer. Correct? So what is the soul of this complete solving? Firstly, we have drawn the ABD. Simply, we have just written the equations. After drawing the ABD, there is nothing about the equations here. See how simply from the past 1.5 hour, what I am doing? I am just writing about the equations. Nothing else I am doing. I am just simply writing the equations, and that's it. Correct? Is it clear? Next one is angle of friction. Angle of friction is nothing but that I've told you, the angle between the resultant between the normal reaction and friction. Normal reaction always act perpendicular, friction always act along the surface. So the resultant will be somewhere between them. So the angle between the resultant and the normal reaction, that angle is called as what? Angle of friction. This angle that is represented, see, this is the normal contact force, and the angle between the normal contact force and the normal, contact force between and the normal, that angle alpha is called as angle of friction. So how you can define? Simply define tan of alpha. Tan of alpha, when you will be writing here, tan of alpha, you will be writing perpendicular upon base, that is friction divided by normal. Friction is defined as what? Mu into n divided by n. It will be cancelled. Can you say alpha is again equals to tan inverse mu? Alpha is also equals to tan inverse mu. These are some values that are given to you to understand. Let's suppose directly the examiner don't want to give you the value of mu, so they will give you some angles, and in the term of angles you have to calculate then what will be the value of theta there, that will be coming there. Okay, so this was the case. Now let's apply this, the complete concept that we have understood till, in the banking question, in the turning of roads. You know that whenever you take a turn, there is always a centripetal force that is required. This much of basics you would be required. So sometime it will be, if friction is not available, we do banking. Banking means what? We used to make the road at some angle theta that is acting towards the center. Okay, now see how we can make that, understand that. Firstly, you have to understand for that what is centripetal force. Centripetal force is not a new force, it is the force that always helps to make a circular motion. This force always acts towards the center. Okay, and it is equals to mass into acceleration, and that acceleration is written as v square by r. Centripetal acceleration is written as v square by r. So net force is equals to mv square by r. Always we used it. See here, a force is taking a curve. That means if it is taking a curve, that means what will be there? A centripetal force will be acting, whatever the centripetal, it is a variety of force, either it will be friction, either it will be normal, whatever it is. So it will be acting towards the center, and the force can be written as mv square by r. Second case, let's suppose you are rotating any bob around it. So I can say who is acting like a centripetal force? I can say simply here tension is acting always like a centripetal force acting towards the center. So I can say tension is equal to mv square by r. Here it is an electrostatic force, and a charge is moving, rotating in a, you know that always a charge is rotating in the atom in a circular manner. So who is providing that circular centripetal force? Obviously Coulomb force. Coulomb force will be giving you the required centripetal force. Correct. Now let's talk about the circular motion of the of a vehicle on a road. Okay. See, let's suppose your car is traveling. Okay, let's suppose your car is traveling and there is no banking or anything, only friction is available on the road. So if your car is traveling on the road and there is nothing extra force, so I can say that there is mandatory that there should be any force that is should be available there. That is a mandatory thing. So what is the force that is required? That means only friction is the component, because mg is what? Mg is always acting perpendicular. If mg is acting always perpendicular, there is no component of mg is going to come towards the center, correct? So I can say friction will be working like a centripetal force. So what is the equation I can write? I can write friction is equals to mv square by r. mv square by r. So what I can say that from here I will get a relation, and how you can write friction? Friction can also be written as mu into mg. That means from here m will get cancelled, and for velocity you can write it is equals to root under mu rg. This is the way how you can solve the questions. Okay. Now there are two cases also. Velocity is equals to mu rg. Let's suppose your velocity is greater. You are increasing the velocity. When you are increasing the velocity, what is that probability? Let's suppose there is a U-turn in front of you. There is a very practical thing. You want to take a U-turn and your velocity is more than the restricted value. Then what will be happening? You will be going to hit in the outer direction of the circular. That means let's suppose you want to take this turn here. If you are coming in very high velocity, that means you will not be able to turn here and you will be moving away. And what if your velocity is so low? Let's suppose you are having a bike here. Okay, if you are having a bike here and you are moving so slow, so you will have the probability to fall towards the center only. You will be having the probability to fall towards the center only. So according to these two situations, friction also adjusts. So what is the direction of friction required? That will be decided by the velocities. So what kind of velocity you are having? Let's understand more about it. Here is a question. A car of this much is moves on a circular track of radius this much if coefficient, then the maximum speed with which the car can move. The maximum speed that we have calculated in the last case, friction is only there. It is the only case of friction. So what I can say, the velocity that we have calculated, that was equals to root under mu rg. So what you can write, what are the values that are given? Mu is equals to 1 by 2, radius is equals to 40, and g is equals to 10. That means it will be 200 root under 200 will be the answer. Somewhere it will be 14 meter per second approximately. You can say the answer will be correct. Correct. Now let's suppose friction is not available. Friction is not available, then who will be responsible? Then what we do, we make the road at some angle theta. Here it is, with this diagram it is very beautifully represented. See, what is the, this is the straight plane horizontal surface, but now what is the road angle? That is at angle theta. Due to that, what will be happening? Normal will be now coming at some angle theta. Correct. Now normal will have two components. One will be balancing mg, and second one will be acting towards the center. If it is a kind of circular motion, that means I can say this kind of circular motion it is going to perform, and somewhere here the center will be there. So who is helping it to perform circular motion? That is the component, that is n sine of theta. So how you will be writing this time? This time we will be writing n sine of theta is equals to mv square by r. Correct. And what about the second component of normal? N cos of theta is balancing mg. Now take the ratio. That means you can say tan theta is equals to mm cancel. You can say v square by rg. That means velocity you will have root under rg tan of theta. If velocity is greater than root under rg tan of theta, then your car, that means what is the safe value? Your velocity should be lesser than the root under rg tan theta. If your velocity is greater than rg tan theta, this car is going to skid away from the center. That means it is going to skid outward direction. Is it clear? That is a minimum required velocity that you have to maintain, that is coming equals to root under rg tan of theta. This is the case of without friction. And with friction already we have seen. Okay, here is the question. Let's understand what is the question. Already we have solved this question. Okay, they are asking for the angle, how much angle you will made, so that you can find. So just simply take the ratio. Tan theta is equals to v square by rg. That means what you can say about the angle, it will be tan inverse v square by rg. That will be your answer. Just now you have seen the formula. So this kind of questions can be coming from the banking. Okay. So case 2 with friction. Let's suppose banking are also there and friction is also there. Then what will be the scenario? Okay. And let's suppose along with that, I've told you now that there will be two cases for the direction of friction. For the direction of friction, if the velocity is greater than the root under rg tan theta, that means you are going at high velocity. If you are going at high velocity, that means what is the probability of you to skid? The probability of you to skid is outward direction. If probability is to skid outward direction, that means friction will be acting towards the center. These are the two probabilities. Either friction will be applied in this direction, either friction will be applied in this direction. When your velocity is higher, that means the tendency to move in this direction is higher. That means friction will be opposing it and it will be applied in this direction. Now what will be happening? This will be a normal. The component of normal n sin theta is going to come towards the center. This is your friction. Here it is your friction. If I will draw the diagram here, understand here more better. This is your normal, correct? The component of that normal will be coming in this direction, and this will be what? N sine of theta. This component will be n cos of theta. Now friction can be applied either in this way, either in this way, because it always acts along the direction of the surface. So friction, if you have the probability to skid in the outward direction, friction will be applied in the inward direction. This will be the friction. This angle is theta, that means this angle is also theta. That means which component of friction is going to come towards the center? I can say F cos of theta is going to come towards the center. That means what I can say about the equation. The first equation about mv square by r, I can say n sin theta and f cos theta both are acting towards the center and they are responsible for making this circular motion, and that will be equals to mv square by r. Or rest of the force you can just balance. Rest of the force, there will be downward direction, it will be f sine of theta. Downward direction there will be mg also. So what you can say, f sin theta plus mg is equals to n cos of theta. Same equation 2 here. From there you will have the maximum velocity that can be achieved so that you cannot skid. The maximum velocity, the formula you have to remember, one time the direct formula was asked in your exam. So the root under rg tan theta plus mu divided by 1 minus mu tan theta. Sign is important, please remember it properly, because the second case, let's suppose your velocity is less than root under rg tan theta. If the velocity is less than rg tan theta, so what is the minimum velocity that you should be acquiring? If you want to calculate that, this time what will be happening? Normal will be same because you cannot change the normal if the angle you have changed, but direction of friction will be changed now. Direction of friction will be changed. Now you have the probability to skid in the inward direction. If you have the probability to skid in the inward direction, that means friction will be applied in the outward direction along the surface. Due to that, what will be happening? Again, two components will be coming. This component will be f cos of theta. This component will be f sine of theta. That means scenarios will now change. Now along the center, if you want to write the equation, how you'll be writing? Now this time they are in opposite direction. This n sine theta and this friction are in opposite directions. That means what you'll be writing? N sine theta minus of f cos theta, because they are in opposite direction, is equals to mv square by r. First equation. Second equation, now it will be balancing. Mg will be balancing n cos theta plus of f sin theta. Mg is equals to f n cos theta plus of f sin theta. These are the two equations that you will be getting from there, and after solving those two equations, again the minimum velocity formula that you will be having, that this is the minimum required velocity that you have to maintain to take a U-turn on the banked road, is equals to rg tan theta minus mu divided by 1 plus mu of tan of theta. Is it clear? Is it clear? This was the case. Okay, two equations, you should be able to understand how actually you have written about the two equations. So what is the safe speed to avoid skidding? You should be in between the minimum velocity and the maximum velocity. You should be in between the minimum velocity and the maximum velocity. Clear? So I hope that this was clear to you, the complete laws of motion, how we have written a lot of equations in this complete one. If you understand those things, then you can go to build your own foundation. Now after that, in the initial way lecture already I have told you that you have to solve by your side a lot of questions. Okay, so now it's time to you to put in your hard work. The reference you got now, a lot of equations, a lot of standard examples we have taken here. Okay, so I hope that that was clear. If still any doubt is there, please comment down. Don't hesitate to ask your doubts or connect to our team with Telegram channel, and a lot of sources are there. Instagram is there, YouTube is already there. So just connect to us. Okay, until next time, keep learning, keep growing with Tapasya. Endigu and then digu Nama Tapasya.